General-purpose branch circuits. These 120-volt circuits supply a number of receptacles used for lighting and small appliances. Some designers and installers prefer to assign a circuit only to lighting or only to receptacles. While this practice is not an NEC requirement, it may be a local code requirement in some communities. It may also be common practice even where it is not an actual code requirement. This approach is advisable for houses that include many permanently installed light fixtures. Small Appliance circuits. These 120-volt circuits supply power to receptacles to which small appliances such as toasters and food processors are to be connected. Typically, these circuits are restricted to kitchens and eating areas. A minimum of 2 such 20-amp circuits are routinely installed in kitchens built within the last 30 years. Individual branch circuits. These circuits supply only one appliance. There are 2 types, 120-volt circuits and 240-volt circuits. The 120-volt circuits service appliances such as dishwashers, food disposers, trash compactors, and washing machines. The 240-volt circuits are for appliances and equipment with greater power requirements such as clothes, dryers, ranges, water heaters, and air conditioners. Understanding electrical capacity. The wires used for conducting electricity offer low resistance to the flow of electric current, but the friction produced by the electrical flow produces heat. A small amount of heat is normal, but when it reaches a level where the insulation around the wire begins to fail, the current must be reduced or turned off to avoid a fire. Vocabulary of electricity. To understand electrical capacity, you need to know the terminology that describes the various components of electric power. These words are amperes, volts, and watts. They describe common functions and are interrelated in precise ways. To comprehend this relationship, think of electricity as similar to water flowing through a hose. Like the water, the flow of electricity must be contained in this case in a wire. The moving electricity is a current called amperes, and it moves under pressure called volts. When you multiply these 2 elements, amperes, current, x volts, pressure, you get the number of watts, which is a measurement of the energy being used, or to state it another way, a measurement of the work being done. Amperes, typically called amps, is the measurement of the number of electrons flowing past a given point each second. It takes 628 billion electrons passing a given point each second to produce 1 amp, which is barely enough to ring your doorbell. Volts measure how much pressure is being used to push electricity through the wire. Thus, the amount of current flowing through a given circuit depends on the amount of voltage being applied to that circuit. Because voltage is a measurement of pressure, it is subject to resistance. This resistance can be measured as well. It is stated in ohms. Voltage alone cannot produce work, but when it is applied to a circuit, a current flows and work is produced. The voltage arriving at a house can fluctuate from 114 to 126 volts. That is why you may see references elsewhere to household voltages other than 120 and 240. Like the NEC, this book refers to voltage as being 120 and 240, the medians of the fluctuations. Watts measure the amount of power being used at any given moment. Taken separately, neither amperes nor volts can tell you how much power is being used. They work together to produce power, which is expressed in watts. To calculate watts, simply multiply volts by amps. For example, a standard light bulb drawing 3/4 ampere from a 120-volt circuit uses 60 watts of power, 120 volts, x 050 amps, 60 watts. Because watts are the result of an equation, variable factors can produce the same wattage. For example, that 60 watts in the light bulb is equivalent to the 60 watts produced when a car headlight draws 5 amps from a 12-volt battery, 12 volts, x 5 amps, 60 watts. Knowing these concepts and the simple amps, x volts, watts formula can help you in many ways as you undertake a wiring project. For instance, if you need to install a new electric clothes dryer, you will have to know what size wire to use and what size circuit breaker to choose to protect the wire. If the clothes dryer is 240 volts and is rated at 7,200 watts, you could calculate the required amperage by changing the AXVW formula to WVA or 7200 240A. The answer is 30, so you would use a wire size able to carry 30 amps, which would be no. 10 copper wire protected by a 30 amp breaker. Each sentence can be long if the input requires it, but must not exceed 30 words.